Good evening. Welcome. Oh, it's nice to hear it back. Thank you. Welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here at Kopernik. And you come on a great night for a great program and what appears to be great skies. So, yeah, yay, exactly. It doesn't always happen. But anyway, I always like to check to see who's here for the first time. Wow, okay, good number of you, all right. Who here are members? All right, pretty much the rest. Okay, very good. What I always like to point out is that people that are members have a piece of information that's particularly valuable. Is that a Kopernik membership not only gets you into Kopernik, on any Friday night and for some of our special events, but also we belong to what's called the ASTC, Association of Science and Technology Centers, and it's a consortium of over 380 other science centers that honor each other's memberships. So with a Kopernik membership, you could go to Roberson, you could go to the Corning Museum of Glass, you could go to the Discovery Center in, the Ithaca Science Center up in Ithaca, or Museum of Science and Technology up in Syracuse, or the Franklin Institute down in Philly, or the Intrepid down in New York City. There's literally there are centers that honor these cards literally around the world. What's nice about it also is that when you do that, you usually get to avoid the big long line of people paying tickets. So, and also a few years ago, I took my daughter down to the Franklin Institute, and had we paid street price for both just an adult and my teenage daughter, it would have been more than a Kopernik family membership for the year. So, if you like this kind of place, consider getting a membership. So, Kopernik has been actually open for over 50 years. It was actually opened in 1974 as a public observatory, and we are now also an informal STEM education facility. We do, in fact, earlier today we had a group from Downsville come up for some fifth and sixth graders came up for some STEM engagement, and but we also do. Pretty extensive summer camp program, and in fact, if you go to our website, you can check out the summer camps. These are camps for students that are going into second grade this fall up through high school, and so you can learn about again, a number of the camps are in fact sold out, but like for second graders and third graders, Space Adventures is still open, Young Naturalists is still open. And so you can definitely check that out. But one of the things that I really enjoy doing are these Friday night programs. It's an opportunity for us to really continue our education, and especially for some of the younger people that are in here, you'll notice that not everyone here is young. In fact, a good number of us have gray hair of what hair is left, or no hair, exactly. And it's really, I think, a great model for you to understand that learning it's a lifelong thing for you to do. It doesn't end in high school. It doesn't end in college. It really is something that we should be doing throughout our entire life. I sort of really wish I could live another, 50 or even 100 years. I mean, I can remember watching Neil Armstrong walk on the moon when I was younger. And that was over 50 years ago. So, and now here we are. Just a couple months ago, we saw we started to return to the Earth. We had those 4 astronauts in the Artemis mission circle the Earth, go around the moon, and come back. And hopefully, within the next 3 or 4 years, we will actually have astronauts again back on the surface of the moon. So, how far has technology come just in those 50 years? And what's the next 50 years going to be like? And actually, that's, especially you young people, that's up to you as to what happens here next. So, so every Friday night, again, we do one of these public programs. But what's also neat about it is that we also offer it on a YouTube channel. So if you go to YouTube and just type in Kopernik Observatory and Science Center, you will see the last 6 years worth of programs that we've done. So last Friday night we had a group of high school students doing their competition robot. We had the the week previous to that, we had a continuation of a virtual reality program. We've had talks about this pursuit of happiness, how science and religion do in fact mingle well. But we've had to talk about ticks. Yeah, we call that the TikTok, exactly. Sorry, I had to. We've even had talk about deep fake and AI. So it's not always about astronomy, although tonight's program is. If you're unable to make it up here in person, you can actually watch on YouTube. And in fact, literally people from around the world would be watching on YouTube live, or they will watch it, at some point in the future. You do not have to get a subscription. Oh, nope, these are totally free.
Because my son subscribes to YouTube.
Right.
So
No, yeah. All you have to do is just if you subscribe to our YouTube channel, that's free, and you're made aware of what programs we have coming up. But also, if you're on the YouTube channel and you're watching our program live, you can actually ask questions through the chat. You have to be a subscriber in order to ask questions. We actually have over 14,000 subscribers to our YouTube channel. But again, it's totally free. And again, so even if you're watching tonight's program, and then maybe tomorrow morning it's like, I got to remember what did Jenny say about this one particular thing. You can go back to that video and and play it over and over again, or stop it and absorb it. So, but along with our Friday night programs, we also have done a number of observing sessions, and so when there's an eclipse or a meteor shower, we will do a YouTube session. And actually, this was a lunar eclipse, and what Jenny, our speaker tonight, who's also our Livestream astronomer, there was a lunar eclipse last March, previous March in 2025, that probably nobody saw because it started at 2 in the morning. And she put together about a 1-minute time lapse. And we'll get to see what that's like. So here's the full moon, and then you start seeing the penumbra the shadows start to cover the moon. And eventually she'll change the exposure on the camera so that you can actually see the red light that's refracting through our atmosphere. Here's that final blood moon that we had. Of course, you also notice that the world did not end. And then she'll change the exposure again as we come out of total eclipse. So these are the kinds of things that we do offer here. So what else have I missed? Is that pretty much it? All right, I think that's good. All right, well, let's dive into here, because I'd like to get into our program, and then also we have a rule. Well, not exactly a law, but it's a rule here that if you come to Kopernik, you can't leave until you look through a telescope. And so, I'll just ask you to leave your keys up here and then we'll check you out on your way out. But seriously, we've got some great scopes that we may be able to still see Venus and Jupiter before they set. We'll do some deep sky viewing as well, and we may even have our imaging scope, our 20-inch scope, up and running, and you can sort of see how that plays. So again, looping back to our Friday night programs, we really have, if you go to experiences, you can go down to the public programs and learn what's coming up. So tonight's program is the summer skies. We will be officially announcing what we're offering this, throughout the summer. I can give you a little preview. Next week is actually a talk about underwater archaeology. And it was actually Dana Karras, who actually was a Kopernik intern, now has a degree in archaeology and is also a scuba diver, and literally scuba dives around the world and does archaeology underwater, and you'll get to see what he offers with that. So go to our website next week, and we'll have that all populated. So again, we're very fortunate to have a number of great resources that we can draw from to talk about continuing our continuing education, but one of which is actually our Livestream astronomer and technology manager, Jenny Cartie, who will be talking about the summer skies. So Jenny, we'll pass it over to you. And
Now it should be. Good. All right. Good evening, everyone. My name's Jenny Cartie, and I'll be taking you through the Summer Skies program tonight. Just so you know, our Skies program it's something we run every season so that we can prepare both ourselves and you for what's coming out in the night sky over the duration of the season. So we're focused on summer now. You're getting a nice preview. We're doing this before even the summer solstice hits. So we're going to cover the whole summer and see what's going to show up. And even tonight, there might be some interesting opportunities if the skies behave, and we'll talk about those. But then, yeah, heading into summer, there's some exciting events too. So let's get started. So as always with our Skies program, this is the breakdown. We start for any newcomers to astronomy with the ABCs of stargazing. Then we talk about what can we see in the sky this time of year, and then some observing tools you can use. Starting with the ABCs of stargazing. And throughout this show, you'll see in the background image, this is a big, important thing that we can see in the sky, especially later in the summer. We see the Milky Way. So our skies are actually one of the more ideal skies in the area for Milky Way viewing, because while we do have some light pollution in our northern sky from Vestal and Bingham 10, by the way, this corner is due north for us. That corner is due south. Our southern skies are all rural Pennsylvania, and the Milky Way, the best time to view it is due south. The core gets nice and high in the sky, and our southern skies are super dark, so the Milky Way really pops and glows. We might talk more about the Milky Way as we go on, but let's focus on the ABCs here. Just to gauge the audience a bit and how much time I spend with this, raise your hand if you've been to one of our Skies programs before. Oh, okay, lots of new people then. That's great. So I will put some time into this so that we can familiarize ourselves with how to navigate the sky. And starting with A, this is for angular size and distance. And the basic idea here is how we can map out the sky from an observer's point of view. And I have a handy trick for you. So angular distance, all that's talking about is measuring things with an angle, how far apart something is in degrees from each other. Because you're a point, you're an observing point, you're looking up. So this thing versus this thing is an angular distance. See how my arms arc across the sky? That's what we're talking about here. So the handy trick is how we can measure that distance between objects. And let's work together on this. A very important part to your handy trick is that your arm has to be stretched out in front of you. Arm's length. And starting with your pinky stretched out in front of you. The width of your pinky is 1 degree across the sky. your pinky nail, the width of your pinky nail, is actually about the width of the moon. And next time you see the moon, I want you to try that. Because has anyone noticed that when the moon is rising, you're seeing a climb above the horizon, it looks big, right? But then when it climbs higher into the sky, it looks small. Next time you see it rise and then climb high in the sky, I want you to measure with your pinky. Measure it at the horizon and measure it high in the sky. Because guess what? It's the same size. It's an optical illusion. Our brains play a trick on us. Because there's things on the ground that are familiar. Okay, those are trees, those are hills. Our brain knows what to make of that. Once the moon climbs high in the sky, you have stars. You have just vastness. So the moon ends up looking smaller in that field of view. But I want you to try that little trick. Prove it to yourself. All right, the next handy trick. 3 fingers, like this. Arm's length. That width is 5 degrees across the sky. If you make a fist, the width of your fist is 10 degrees. And then, hook 'em horns. My family would be mad at me if I don't say that. Then you do 15 degrees across the sky with your pinky and your pointer finger. And all of those combined, you can start measuring the distance between objects in the sky. So what's this right here? The Big Dipper, very good. And we can measure the stars throughout the Big Dipper. And the Big Dipper does come out tonight, so we can try that. So 10 degrees here across the cup of the dipper. It's 5 degrees in height, 15 degrees here, and then the total length is 25 degrees. So, and feel free if you want to take, of course you can get these on YouTube as well later on, but if you want to take pictures of the slides, especially for use tonight, go for it. Because you can practice this with the real Big Dipper this evening. All right. So B is for brightness. Now we know how to measure things in the sky distance-wise. But another characteristic is measuring how bright things are in the sky, because that is a huge range. So in astronomy, we also call this magnitude. And this number line is how we measure this magnitude or brightness. So one thing you're going to notice right away is the number line might not make sense at first. Because, okay, we have on this side very bright, on this side very faint. These are negative numbers. These are positive numbers. So this isn't very intuitive. I'll explain the story quick with this number line. Astronomy is one of the oldest of the sciences. And star classification started happening very early on. And the initial way star classification worked was a ranked system. So if you were a really bright star in the sky, you got rank number 1. If you were a really dim star in the sky, you were in like 5th or 6th or 7th place. So bigger numbers meant dimmer stars. Smaller numbers meant brighter stars. That classification evolved over time, but we had to start accounting for everything in the sky once we started to establish the science more and more. So the sun, which wasn't included in the original classification, ends up out here towards -30. And the moon, which is the next brightest object in the sky, out here towards -13. Then we get to planets like Jupiter or Venus. So that's more -3 and 4. A good 0 marker star is the star Vega, which will be visible tonight, a nice bright star. If you've read the book or seen the movie Contact, that's where they hear the signal from. is that star. Andromeda Galaxy. If you look at the next point over, about 6, magnitude 6, is the faintest naked eye object that we can see. So the faintest object we can see in our eye, with our eye in the sky. But the Andromeda Galaxy is before that. So that means you can see a galaxy with your eye, and a good portion of it too. So that's pretty neat. We can see a galaxy as long as the skies are dark enough. But yes, around 6, that's where we hit too dim to see with our eyes. And that's where our tools need to take over, binoculars or telescopes. And even better, combined with a camera. So then we can really start collecting that very, very faint light of objects that are dim, like nebulae. The Ring Nebula we cannot see with our eye, but we can see with a telescope. And then the fainter and fainter you go, there's also, in a way, you'd be looking deeper and deeper into space. So James Webb Space Telescope, for example, is looking at things way out here, so that it's looking deeper in the universe than any telescope before it. So we have dim on this side and bright on this side. You will see these numbers come up in another section of our talk. In the end, when you're describing with the person next to you, you don't have to use a number line like this. You can say that really bright one or that really dim one, and then use your handy trick to start measuring. It really ties together, because when you're trying to just point something out in the sky, that doesn't super work. If you've ever tried that, especially with something dimmer, you're pointing to it, but to the person next to you, you're pointing to something else completely different. So this is where that handy trick ties in, and also where describing brightness ties in. And then finally, we have coordinates. C is for coordinates, and this is where we can really map things out. So there's 2 systems we can describe in the coordinates of the sky. The first one isn't too far off from how we were discussing angular distance. So altitude and azimuth coordinates. This coordinate is from the observer's point of view. So here's our observer standing out in a field looking up in the sky. And your azimuth, this is the azimuth, going all the way 360 degrees around you. Those line up with your compass directions. So north is 0 degrees. East is 90 degrees. South, 180. And west, 270. Again, your handy trick works with this. It would work perfectly to measure those angles as well. All right, so that's your azimuth. Then we have your altitude, climbing high in the sky. And your altitude goes from the horizon, and ideally a true horizon. Here at Kopernik, we have some trees. So that's where objects will appear to horizon set, but we have a true horizon. And you kind of have to follow the ground to track that. So keep that in mind. You're looking for a true horizon. Think about the ocean. That'd be a true horizon. So altitude, though, from the horizon up to zenith. So 0 degrees at the horizon and 90 degrees at the top of the sky. That one only goes 0 to 90. So rotating is your azimuth, and up and down is your altitude. So we have some examples here. Let's just pick any random star here in the southeastern sky. That star in altitude goes from 0 to 50 degrees in the sky. And remember, your fist is 10 degrees. So you can count 10, 20, 30, 40, 50, and so on, counting up from the horizon. And then your azimuth, measured from the north out here to the southeast, is 150 degrees. So that's the coordinate of that star in the sky. We've mapped that out in this instance of time. The North Star has an azimuth of 0 degrees because it points due north, and an altitude of your latitude. Does anyone know your latitude right now? That's pretty cool. Yeah, it's 40, here at Kopernik, it's 42 degrees latitude. And that means that if you can find the North Star, you can always find your latitude, combined with your handy trek. And again, your latitude on Earth is this from the equator, 0 degrees up to 42 degrees, where we are. All right, so that's one coordinate system. We've got one more, though, and this one's super important for telescopes because the issue with altitude azimuth coordinates is that, yeah, we can, at least for a minute or two, the coordinate I give you of that star in the sky is pretty good. Even for 10 minutes, it might be pretty accurate, at least just pointing it out. The problem, though, is the sky does something throughout the night. What does the sky do? Any thoughts? It changes. Yeah. The sky changes. The sky spins. It appears to rotate. And the reason for that is because Earth spins. When Earth spins, the sky appears to move. It's why we have sunrise and sunset, day and night. The stars are also going to move at that same rate across the sky. So our altitude azimuth isn't great if we're just measuring from the observer's point of view. If we want to give these things in the sky their own coordinates that they keep forever, or at least close to forever, for as far as a human lifetime is concerned, we need a new one. And this is the equatorial. So here's the Earth in space. And surrounding the Earth, this is just a model. Space isn't just a shell around the Earth. But it does work. This model works from our point of view on our planets when we're talking about how things in the sky move. So here's the Earth at the center, and here's the shell we call the celestial sphere. It's the entire sky surrounding the Earth. Now, just like on our Earth globe, the Earth globe has an equator right here. If we take Earth's equator and we send it out into space, so you're just growing the equator, that ring, out into space, you get the celestial equator on this sphere of stars. Okay? So we've sent the equator out into space, and now we have that mapped. Then, this should look familiar. This is basically latitude. So these are your space latitude lines. 0 degrees, 15, 30, 45, 60, 75, and up to 90 at the top there. This is the north pole of the celestial sphere. This is the south pole of the celestial sphere. And that equates to latitude. We call this piece in astronomy declination. So latitude becomes declination here. Then we can map out the path of the sun through this sphere throughout the year. So that green line's the path of the sun at different points. And actually, if I go back a step, because it's getting really messy. Hang on. Let's go to this one. There's points in this path of the sun that may look familiar. You're basically looking at seasons here. So here is the vernal equinox. Does anyone know what season that is? Spring. Here is the summer solstice. That one, pretty clear. And then out here, we have the autumnal equinox. That's fall. And then down here, we have the winter solstice. So that path of the sun Also shows you the seasons. It's also where we can mark out a 0, 0 marker. So 0 degrees in both declination and 0 hours in what's called right ascension, which is basically your longitude. So you can count around there. And then finally, when you piece this all together, you can give anything in the sky, any star in the sky especially, specific coordinates in equatorial. And this map moves with the stars in the sky. It keeps up with them. So they all have their own coordinates. This is super important for telescopes. Like all three of our telescopes talk to the sky in this way with equatorial coordinates. So that's how we map things out. Oh, before we move on, I just want to show you a physical model of that. Because up here we have the globe of the Earth. We also have a globe of the celestial spheres, so you can see constellations on this globe. But this combines it all together. This has the Earth inside that can spin. And it has the celestial sphere around it. So I'll just come down the aisle here and show this globe up close. Okay. So you can see those stars on the sphere and the globe inside. What's that? Oh, yeah, here you go. Of course. Yeah. All right. Oh, there's my remote. So, I want to show you one of our first tools that you can use. If you go to the website stellarium.org, that's stellarium.org. This is your at-home planetarium that runs just about on anything. You can get it for any PC platform, Linux, Mac, Windows, or there are versions for smartphones, for tablets, and there's a web-based version as well, which I'm going to show you now. Stellarium Web, and there's that mobile version over there. Now, first thing we have to do is make sure we're not in Booth Bay, because everywhere I go, Booth Bay follows me for some reason. Stellarium seems to really like that location. All right, so here we are in the town of Vestal now, and this is what the sky looks like. If I switch to current time, this is what it looks like right now. So we still have some twilight we're working with at the moment. We can click and drag around the sky. And if you've ever been in a planetarium before, this is working the same way. It's just happening on a flat screen instead of all around you. So we have our north, our south, east, over here is west. And you can see there's a lot going on in the western sky right now. Now this is also a time machine, so you can look ahead into the future. I just skipped it an hour ahead to see the stars. You can map out constellations. You can map out the constellation artwork. You can see how the skies move by just gently moving through time. So going minute by minute, you can see how the sky is. Things in, let me line it up with south. There we go. You'll see that objects in the east are rising and objects in the west are setting. And there comes the moon heading towards 1 o'clock in the morning. All right, you can also map out those coordinates too. This is your azimuthal grid, which is Alt-Az from the observer's point of view. And if you watch this, traveling through time, notice the stars move through this grid. Or we have the equatorial. And in this one, the grid and the stars move together. So that's a quick overview of Stellarium. We're going to come back to it during the show to keep exploring. So what can we see in the sky this spring? Let's find out. Well, one thing this summer. That was a mistake. So International Space Station. So while this won't be visible tonight, we will have lots of opportunities for it. The International Space Station is the size of a football field. It is a massive spacecraft. And it's where people go right now primarily to explore the stars and really explore the Earth. They're not too high above the Earth. They're only 250 miles up. So 250. And that orbits the Earth once every 90 minutes at 17,500 miles per hour. So it's zooming. And when it does fly over, you usually can get a couple sightings of it per night. At that speed, though, you could travel from New York City to Los Angeles in 9 minutes. So it's zooming. And I'm going to show you the website where I got this data from, but these are ISS flyovers coming up. We still got to wait a little bit, and on top of it, right now, they're morning flyovers. So you can see these are happening 4:31 a.m., for example. All right. So I'm not going to highlight these too much because they're a little ways off, and they're not convenient hours, but I will show you how you find these. Loading. Maybe. Let's try again. Well, we're just going to do a search for it. Unless that doesn't even want to work. Heavens above. Try that. Unless their website isn't working right now. Well, that's not going to work today. All right, that's okay. If you go to heavensabove.com, that's where you can go to put in your location, and then you click on the ISS, and that will take you to what sightings will be visible. So as we head into the next month, we should get some evening sightings for ISS. And yes, that is naked eye. When it flies over, it can be as bright as Jupiter or Venus. And I think I even have, let's see. Let me bring this back full screen. Yeah. So we're going to check who's on board, but that's what it looks like when it flies overhead. Little star in the sky, no blinking lights. All the light coming off the ISS is sunlight reflecting off those solar panels and the spacecraft. So let's take a look at who's on board the ISS, or even better, who is in space. There is a wonderful website literally called whoisinspace.com, which tracks how many people are in space and where they are. So there are 10 humans in space right now. And you can scroll down and see on the ISS Soyuz MS-28 mission. The Soyuz always flies with 2 cosmonauts from Russia and 1 NASA American astronaut. And then ISS SpaceX Crew 12, very similar. You'll get usually a couple of American astronauts, a cosmonaut, and then usually one from the European Space Agency or JAXA, the Japanese Space Agency. So on the ISS, there are 7 people in space there. But there are 3 more total. We had 10 people, right? And there is a second space station called the Tiangong Space Station, and that's built by China. So these are 3 Chinese astronauts. Now, what was really cool about whoisinspace.com was during that 9-day Artemis 2 mission, they showed up here too. And we should be seeing more of that, especially because NASA is interested in building a moon base, which would be more long-term living. It wouldn't be a 9-day mission to the moon. It would be long-duration stays on the moon's surface. So this website could get very interesting in the next few years. It's already interesting, but all right. So now let's go through the solar system. What's out there of the solar system to see in the sky this summer? We have the sun. Now, solar maximum happened from 2024 to 2025. That's when the sun hits peak activity. You get a lot of these sunspots on the surface, those dark spots, and those create and cause solar storms, these coronal mass ejections that leave the sun and sometimes find their way to Earth. And usually, not a problem, might cause some communication issues. But we will talk about what they can do, which is more exciting, more positive. Of course, big caveat here, the sun is the only dangerous object in the sky. You don't want to stare at it with your eyes, and you don't want to look at it with binoculars or telescopes, unless you're at an observatory like Kopernik that has safe solar equipment. So don't look at the sun unless you're here with us, and we can show you how to do it safely. But, oh no. Oh yeah, I did have that in there. Before we get to what else you can do, I'm going to show you that there is a partial solar eclipse coming up. And a solar eclipse is when the moon passes in front of the sun. And this is showing us maximums. This is August 12th of this year. We can start at the beginning and show you around 1 p.m. our time. The partial eclipse begins. There's maximum eclipse, just biting into the sun a little bit. And then it wraps up at about 2:30 p.m. This isn't a very deep eclipse for us. There is a total eclipse happening. I think this is the eclipse path you're seeing here. So up in like Iceland and stuff, they'll see better versions of this event. For us, though, it's just a very tiny partial eclipse. Still, it'll be cool to see, but the only way to safely observe this one, if you have eclipse glasses that are in perfect condition from 2024, that means no holes in the lenses, no scratches. You can view this event with those eclipse glasses safely. Or, stay tuned from us. We'll see what, that's during our busy summer season, but you never know. And sometimes we do live streams and things like that for events like this. All right. Go back. Now, you can also see an effect from the sun. Like I mentioned, those big solar storms that happen create these northern lights in our skies. And these are beautiful displays. You can see this pillaring here. This was from August 12th of 2024. There's a wonderful gradient of color, and this was during a particularly strong storm. So this is a camera obviously picking this up.
Yeah, I was going to ask about that.
Yes. So for this storm, to give you an idea of what our eyes were seeing during it, we could see the pinks and we could see the greens. They just were faded. They weren't quite as vibrant as what we're seeing here, but they were noticeable. And you could see the pillaring as well. And we watched this display play out over a couple of hours. And it changed in beautiful ways. There was also some pulsating aurora, which are these really almost like fireworky displays, which were fun to watch. So that's something that can happen. And a great website to go to learn more is spaceweather.com. What is cool, and again, no guarantees for this, But if we go to spaceweather.com here, you'll see that it reports there is a geomagnetic storm underway right now. So it's saying it's a G2 class moderate geomagnetic storm, and it might increase to a G3, which G3 is where we can start seeing it here in New York. So if it was to do that, I'll come down here and show you the data. This is what, the green is where it was earlier today, which means really no chance to see much unless you're towards the North Pole. But those yellows and then really the orange and then into this 7, this next step up, which would be G3. That's what we would want to see. So it's a darker orange. So if that happens in the next hour or so, maybe we'll get to see something towards the northern horizon. But this is how you read this. And there's, even though the sun is moving out of solar maximum, there are still opportunities, like tonight, to hopefully catch those northern lights.
Is that maximum thing on a 7-year cycle?
That is 11 years. Yep. So yeah, in the next few years, the sun is going to become very quiet. There's not going to be much in the way of storms happening. All right, the next object. Now from here on out, all these objects are safe to look at with your eye. The sun's the only one that's dangerous. The moon, though, the next brightest object over. The moon is very dynamic in our skies. From day to day, you can see it change as it goes through its phases. One lunar cycle is 29.5 days. So this marks out the phases that we'll see from new moon to full moon, which takes about 2 weeks, and then 2 weeks more brings you back to new moon. And through there, from new moon to full moon, you are waxing, meaning you're adding light. And from full moon to new moon, you are waning, losing light on the moon. What was kind of cool, if you watched the Artemis 2 live stream day to day and saw their approach out to the moon, for a while there, while we were losing the full moon here on Earth, as it goes through this rotation around the Earth, the Artemis 2 astronauts were just keeping up with that rotation as they flew out and kind of saw a full moon throughout the duration of their flight until they started to wrap around it. But the cool thing is their full moon that they were seeing was showing parts of the moon we never get to see here on Earth. The moon is tidally locked, so we only get to see one side of it from our planets. It's not like we don't know what's out there, though. NASA spacecraft have fully mapped out the moon and have seen that far side. Apollo astronauts got to see some of the far side. Artemis 2 astronauts got to see some of the far side. And actually different parts of it, too, which is neat. So the Artemis 2 astronauts got to see parts of the far side that no human has ever seen before with their eyes directly. But yeah, observing, unaided eye, of course, binoculars, telescopes, cameras, anything. You can look at the moon and look at it as long as you like. There is a partial lunar eclipse coming up in August as well, August 27th. This one is going to be a little bit more dramatic, I would say, than the partial solar eclipse. So let's take a look. There was a total lunar eclipse in March of this year and last year. And that's where the moon fully enters the Earth's shadow. This one, it's going to partially enter the Earth's shadow, but it is going to move pretty deep into it. So there's only going to be this little bit of light left over. So a good portion of the moon will be noticeably this orangey red color during this partial lunar eclipse. And if we look at the times, I think this is what's really exciting, because the March one, not only was it cloudy, but it was also like very early morning hours. This one, even though it's not total, it starts at 9:30 p.m. Much better than like 2 a.m. And then as we head into Earth's shadow, that's 10:38 p.m. Maximum eclipse happens around midnight. And then partial eclipse ends at about 2 a.m. So you do have to stay up a little bit late to see the whole thing. But at least those early stages will be more convenient hours. By the way, this website is timeanddate.com. Really good website for looking up eclipses. All right, so we got an eclipse coming up. And that picture we took at Kopernik during the Pi Day eclipse in 2024. All right, what planets are out? There's a couple planets out even right now in the western sky. Venus and Jupiter. And what's exciting about these two objects, while it's not technically happening during the summer, I'm still highlighting it because we're hitting it before it occurs. There is a nice conjunction of these two objects happening on June 9th, where they will be 1.6 degrees apart. Your handy trick, right? Your pinky stretched out, that's thereabouts how far apart they will be in the sky. Basically a pinky and a half, yes. So they will be very close to each other, and they should appear in a nice pair of binoculars. They'll appear in the same field of view. So I'll show you what that looks like as a preview in Stellarium. Let me show you how the time travel works with that. We're going to go back to current time. We're going to turn off a few things too so that they don't distract us. Here's where Venus is in the sky right now, setting in the west. There's Jupiter. And if we go over to the clock window, we can time travel to June 9th. So let's go day by day, see how things change. June 6th, 7th, 8th, 9th. And they are right on top of each other there. And get things a little bit darker. The only trouble, of course, is best to catch them in the early evening. They will set pretty quickly if you wait too long. So if it's clear out on June 9th, step outside and see just how close they'll be in the sky.
They should be quite visible.
Oh, yes. Yep.
Immediately after the sunset?
Not quite immediately. I would give it like maybe 20 minutes to 30 minutes. But after sunset.
The sky is still light blue. It's illuminated.
Yes.
Okay.
Yeah, in twilight you can see them. Yep.
That's what I meant to say.
Yeah. Oh, absolutely. Yeah, you should see them. They're pretty similar in brightness, and they're getting closer every day. Yep. All right, so those are the two planets that will be visible at convenient hours. Most of the summer, though, we'll lose these two, and the only options will be waiting into the early morning hours to see some of those ones coming up like Mars and eventually Saturn. So summer, over the last few years, has been kind of devoid of planets for a good portion of it. And this year won't be too different unless you wake up early or stay up late. All right. We did that. Ooh, another solar system event. Perseid meteor shower. This is my favorite meteor shower. It is amazing. The predicted peak is August 12th into the 13th. And you should expect about a meteor per minute during this shower. So this tends to be one of the most dramatic ones of the year. And this year is also really good because if we time travel again, skipping to August and the 12th, if we search for the biggest problem during meteor showers, the moon, oops, the moon will have set that evening. So the moon doesn't get in our way, the skies will be super dark, and that's the best time to see these meteor showers. So we will most certainly hold events for the Perseids we do every year, usually a couple of days to give you some options to come up and see those meteors up at our site. So look out for that. Also, by the way, this is a picture of a Perseid meteor shower here, and below it is the Andromeda galaxy. So that was taken around the peak of the Perseids a few years ago. Oh, Perseid meteors do tend to be green because there's a lot of nickel in them. And just like fireworks, different colors of fireworks are because of different metals and elements within them. That same thing happens with meteors when they burn up in the atmosphere. That aurora I showed you earlier happened during the Perseid meteor shower. So there was a lot of fun things going on that night to observe. And this is a Perseid meteor here shooting through the aurora display above the Science Center. So yeah, we're excited for Perseids this year. Deep sky objects. We talked about the Milky Way earlier. You could argue that Milky Way, at least the part of it we're seeing all this glow, like the core of the galaxy, it's not traditionally what you would call a deep sky object, but it is in the realm of things we're talking about here. So what do I mean by that? Let's go through and explore some of them. So the Milky Way is our galaxy. We live inside it, and it ends up being a huge structure across the sky because of it. Galaxies are massive structures filled with billions and billions of stars. So there are galaxies beyond ours, of course, billions and billions of galaxies out there, including this one, the Whirlpool Galaxy, M51. By the way, that M, it's a catalog of different objects, of deep sky objects. So it could be star clusters, galaxies, nebulae, where stars are formed or where they've died. And it stands for Messier. Charles Messier was an astronomer. He was especially a comet hunter. And people kept asking him, is this a comet that I'm viewing in the sky with my telescope? Did I find a comet? Did I discover one? And he's like, no, I've been asked this 100 times. It's not a comet. Please stop asking me. And eventually he started this catalog, which was the Not Comet catalog. We didn't really know what they were yet, but now we know that they're quite a bit more interesting than comets. Comets are interesting in their own right, but they're also small compared to the things we're looking at here, like star clusters and galaxies. This galaxy has probably trillions of comets in it. And this is the Whirlpool Galaxy, two galaxies colliding together. So this bigger one here is basically eating up this smaller one, and eventually the cores will merge. This happens very slowly because they're very big structures, but it's a collision in action. All right, the Pinwheel Galaxy, M101, there's another Messier number. And both of those were taken through our largest telescope, the 20-inch reflector, which when you go out to the scopes, you'll see that one. What was cool about this image of the pinwheel from 2023 is that there was a star in this image that was not there before, right there. That big bright star was a supernova. And the supernovae are pretty dynamic out there in galaxies. One of the best ways to see them is through full-facing galaxies like this. You can just study them and watch them. And because there's billions and billions of stars, you're likely to watch a supernova at some point. But they happen pretty quick. They're big, energetic explosions. And so they come in and they fade over the course of a few months. So that was the brightest point of that supernova. And now that star is basically gone. Not physically gone, there are remnants of it. You know, if it was a massive enough star, maybe it became a black hole. But in imaging these objects, you will not see that star there, or very much evidence for it. The Andromeda Galaxy, M31. This is that galaxy I showed you in the Perseid image. And this is our neighbor galaxy. It's the one that's closest to us. And there's a couple of satellite galaxies around it as well, here and here. So Andromeda is visible to the eye. You don't need a telescope, but of course, you'll see more if you get a telescope set up. Trifid, M20, and the Lagoon Nebula, M8. These are star-forming regions. Whenever you see this red or pink color, that's evidence for stars igniting and energizing, and there's all this stellar activity. So Lagoon especially is a stellar factory, where all of these in this cluster are young stars that recently formed, and there's still stars forming at the core of this nebula. Same thing over here with Trifid. It's views as a smaller nebula, not as heavy of a cluster of stars there, but there are two bright stars, one in each of the colors. You see a blue and you see a pink. The blue is just starlight reflecting off clouds of dust and gas. Again, the pink is actually glowing. It's cloud glow from all this hydrogen that's all excited and energized. So we can see nebulae in the summer. And these two objects are right towards the core of the Milky Way galaxy. So there's a lot of nebulae we get to see in the summertime. So there's another view of the Trifid up close, M20. And here is not where stars are being born, but where one has died. This is also called a nebula, but it's called a planetary nebula. Don't let that confuse you too much. The reason it's called planetary is in a telescope, they do kind of look like planets to the eye. They're these little glowing orbs. And that's no different for the Dumbbell Nebula. And if you look carefully at the center of this one, right there, you will see the remnant star. So this may have been a star, probably a bit bigger than our sun, but either way, not too dissimilar from our own. These stars don't go supernova. They just expand out their outer layers into space. So that's what we're seeing here. So we're going to skip that today and just show you some observing tools you can use. We already talked about Stellarium. So there's the website where you can download Stellarium. But there are some other apps too, if you want to try something else. These all work similarly. In principle, they're maps of the sky, but they scale up in features. Although I would argue Starwalk and SkyGuide pretty similar in functionality to Stellarium. It's kind of just which one looks nice to you. They also have notification systems of their own design, so you can look at those too and see what kind of news they report, and if you want that to pop on your phone. So those are great apps. There's free versions for each of them, and there's also paid versions, I think. And then Sky Safari is the most advanced of these applications. So I would hold off going straight to that one. But eventually, if you get your own telescope, the Sky Safari actually supports telescope control. So I would consider that as you continue to explore. I also want to show you that you can just use your smartphone for imaging. So both of these pictures were just through the lens of this camera on my phone. You can use your smartphone to take pictures through telescopes. In fact, we have a scope of that kind, an adapter that we can hook up to scopes and take pictures that way. But when I'm just out and about, this is the camera I have on me. What can I do with it? This is what I tried to do. So I took a picture of the moon as it was rising in the sky above Kopernik. So you can see some decent detail. This is just a single shooter. It's not a telephoto lens. So with a little bit of cropping, you can make out some detail on that object. Where's my pointer? On the moon there. There it is. So you can see some of those C's, those dark patches of the moon. And then this one I actually took just last night when I was practicing with the 20-inch telescope and imaging the Whirlpool galaxy at the time, which the Whirlpool galaxy is like right in here, in that part of the sky. But can you see a familiar object there? The Big Dipper, yeah. So the Big Dipper is in this field of view, and I just looked up at one point and realized, oh my gosh, the Big Dipper is like perfectly framed as I'm imaging. So I took that picture out the dome. So yeah, you can do some pretty incredible stuff. Most modern smartphones from the last few years have a mode called night mode. Or I think even Android smartphones have a full-on astrophotography mode. So dabble with that a little bit. There are ways you can increase the exposure to get some really nice images of stars in the sky. And you could even practice that tonight. And if you have questions, you can ask us. All right. With that, though, I get to say actually clear skies this time, not just hoping clear skies. And yeah, I'm happy to take any questions.
If you do have questions, we're going to just bring the mic over here so that people on the live stream can hear. Any questions come to mind?
All right.
Well, it's a sign of a great presentation because whatever questions they did have, you answered. So
okay, cool.
And same thing with the on the chat. It's also
Okay.
good. So,
Sorry.
so thank you, Jenny. I really appreciate once again.
Thank you, everyone.
So now we invite you to head out. If you go straight through those doors and you go straight, there's another set of double doors sort of across from the lobby. If you take a left, there's a little hallway, and then you go to the right, and then we'll have our 6-inch telescope open. I believe they're looking at Jupiter now, or will be. And potentially a little bit later on, we may have our 20-inch telescope open and operating. But also we've got, there's an astronomy club that operates out of here. That is the Kopernik Astronomical Society. One of its members, Keith Workman, brought his 18-inch telescope. So you get to see people that are really into this, where you can spend your money. So again, invite you to take a look there. We'll maybe do a bit of a night sky tour of what's out there. There were some clouds that were starting to come over, but those clouds keep moving, so there will be stuff to see. And we invite you to come back again next week for the talk about underwater archaeology. So thanks again, and look forward to seeing you soon.